We want to look at how to solve most algebra problems, pretty much even Algebra 2 problems. If we use a certain procedure and follow these rules, and if we understand the balance of math, the way plus and minus are opposites of each other, and multiplying and dividing are opposites of each other, and if we understand PEMDAS, we'll be on our way to solving almost any problem that we encounter, and we'll make sure to get it correct. So, three things we want to look at. The first thing is PEMDAS. Most of us remember that PEMDAS is the way we calculate things in math. Because if I don't follow a certain order, when I calculate something here, let's say in this country versus another country, we would have different answers, and we can't do that. Math has to have the same meaning everywhere. So what we learned was PEMDAS was, we would even say, please excuse my dear Aunt Sally. We calculate from left to right. First we look for parentheses or exponents in a problem. Then after doing parentheses and exponents, we get to multiplying or dividing from left to right of the problem. And then lastly, from left to right, we look at any adding or subtracting. So for PEMDAS, we go from left to right, and we follow these groups of two, these pairs. And one problem that we used to see on Facebook a lot is a PEMDAS problem. So if we take this problem and we don't follow an order, we can get two answers, either 1 or 9. So using the order we've just reviewed, we're going to look and see if there's any parentheses or exponents. And here there's a parentheses. So I'm going to do what's in the parentheses. 1 plus 2 is 3. Now I'll look to see if there is another parentheses or exponent, and there isn't. Then we look to see if there's any multiplying or dividing. And there's a division here, so I'll do that next, from left to right. So we see there's dividing and multiplying. We follow the rule from left to right, so we would do the division first. 6 divided by 2 is 3, and then now we have a multiplication. We do 3 times 3 is 9. So when we're doing PEMDAS, we use it to calculate and get the right answer when we have only numbers. When we're going to be solving, we're going to be using PEMDAS, but we're going to do backwards. We're going to do adding and subtracting, then multiply, dividing, then parentheses and exponent. Another thing to keep in mind are some opposites, things that you may know and sort of take for granted. If we think of a number line as a scale, where 0 is the balance, when we have a positive number like 1, when we add it to the negative 1, it creates a balance, and 1 plus negative 1 gives you 0. So the opposites of things create a balance in mathematics. One thing we had mentioned in another video, when you look at algebra visually, the variable x is like a row of some amount of bricks, and both rows are the same amount, we just don't know how many. And let's say there are 2 more bricks. So let's say, make it easy, that you have 3 rows of something with 2 more bricks left over, and you have 32. As we're trying to understand and calculate this, we do the opposite to both sides. So we say, well, let's take away these 2 bricks. So then 2 have been taken away from the total. So for 3 rows, we would say originally 3x plus 2 equals 32. That's what this really would be representing algebraically. We subtracted 2 on both sides. So what we tend to do is draw a line down the equal sign to remember what you do to one side, you do to the other. So now we have 3x equals 30. So if you have 3 rows of something that make 30 bricks, you know that it would be 3 rows of 10. And what we do is we divide both sides by 3. So one thing to remember that's also very important is what 3x means. 3x is really multiplying, 3 times x. And we kind of take it for granted because we don't put the marking there. 3 times x. So the opposite of times is divide. That's why we're going to divide. So we're going to do the opposite of things. Here we were adding, the opposite was to subtract on both sides. Here we're multiplying, 3 times x, so we're going to divide on both sides. So what are our opposites we want to keep in mind? We have plus, the opposite would be minus. We have multiplication, and the opposite of multiplication would be division. We have squares. The opposite of a square would be square root. There's an invisible 2 there. Even cubes, the opposite of a cube would be a cubed root. And this will apply to even sine, cosine, and tangent in trigonometry. So sine, the inverse or opposite is the inverse of sine. And these things will give us a balance and help us to solve to get x alone, which is our goal when we're solving algebra problems. So we want to remember the balance. It's kind of like the little yin-yang sign. You draw a circle, and then another circle half the size, another one half the size, and they would have two colors. And I tend to think of it as positive and negative, or negative and positive. So you have a balance. Same as in chemistry, your atoms have a positive charge and a negative charge. So the last thing to keep in mind, as I had mentioned, 2x means 2 times x, so we can remember that the opposite of 2 times would be divided by. So we could begin our main lesson or main objective. When we're calculating or solving with just numbers, we use PEMDAS. When we're solving for a variable or using algebra to get x alone, we want to use PEMDAS backwards. So I'm going to go from the left to right. So I'm going to write down PEMDAS, and we're going to start at the bottom. We're going to do any addition or subtraction first. So let's take a basic problem and just have x plus 3 equals 10. Now many times people say, well, I know 7 plus 3 makes 10. But when you have a more complicated problem with bigger numbers or more to it, you can't always do it in your head so easily. So we want to know and understand the process or the steps. So it's kind of saying a row of something plus 3 bricks gives you 10 bricks. Well, a row of 7. So we're going to do the opposite. We had said you can draw a line down the middle here, and we look to see if we have any addition or subtraction. And we do, plus 3. So we're going to subtract and do the opposite on both sides. X equals 10 take away 3, or 7. So when you have a two-step problem, it will work the same way. You could say 2x plus 3 equals, let's say, 13. So now again, we're going to look to see is there any addition or subtraction we can do, and there is. There's a 3. So we're going to do the opposite of plus 3 to both sides. We're going to subtract 3, subtract 3. So 2x equals 10. And we want to remember 2x means 2 times x. There's a little invisible multiplication here. So next we look at the PEMDAS backwards. We ask, do we have any multiplication or division? And we do. We have 2 times x. So we would do that next. We would do the opposite of times, or divide both sides by 2. Okay, and the goal is to get x alone, which is why we did that, because 2 divided by 2 was really 1x equals 10 over 2, or 5. And we usually don't write 1x, but technically 2 over 2 is 1. Now we cancel it out, it doesn't disappear, it becomes 1. Let's do one with even more steps. We could do 2x squared plus 1 equals 33, let's say. And again, we're going to look at PEMDAS and follow PEMDAS backwards. I'm going to go from the bottom up. Are there any addition or subtraction? There are, plus 1. So I'm going to subtract 1 on both sides, do the opposite. 2x squared equals 32. Next, I'm going to ask and look to see if there are any multiplication or division. 2 times x squared would be multiplication, so we divide both sides. That will cancel out. X squared equals 16. Now we can look at parentheses and exponent, and we have an exponent. So what we had said is that something squared, the opposite of that would be a square root. And there's a video I made on what a square really is, talking about a square. So the square root is asking what's one of the sides of that square. So when you have 16 bricks, how many bricks are in each side of the square? And the square has a total of 16 bricks. In any case, we would do the opposite of squared or square root both sides. And we learned that in algebra, we square root something, it could be positive or negative. And then you can use a calculator, or hopefully you understand how square roots work. 4 times 4 gives you 16. So really we're saying if you have a square with 16 little bricks, it would be a 4 by 4. So the square root of 16 would be a 4. Now, technically negative 4 times negative 4 is also 16, so we always put a plus or minus when solving a square root because a negative times a negative becomes a positive. But in real applications like building something, you would never use a negative number or a negative amount of bricks, let's say. This will even work with sine and cosine and tangent as well. So I can say 2 sine squared x equals 1, let's say. Or actually, let me subtract 1. So we could take this problem and then set it up and use a calculator to solve it. We're still going to ask, are there any addition or subtraction? And there is a negative 1 or a minus 1, so I'm going to add to both sides of the equal sign. So we have 2 sine squared of x equals 1. I'll see if there are any multiplication or division, and there's a multiplication, 2 times sine. So I'll do the opposite, divide. So now I have sine squared of x equals 1/2. Next I have parentheses, or an exponent, and we have the exponent, sine squared. So we're going to do the opposite of squared. We're going to square root both sides. And so we have sine of x equals the square root of 1/2. And I will use a calculator for that, because getting into the square roots will be a whole other lesson. So I'll take 1/2, 1 divided by 2. It's one other thing to consider. We'll look at a problem like that. 1 over 2 division is really what a fraction is. So we have half, the square root of half is 0.7071. So the last step to get x alone, if you notice here, we have the word sine next to it. So what we had said is the inverse sine, the opposite of that would be the inverse sine. So to do the inverse is really like dividing by sine. So we get sine over sine, or 1. So if I do the inverse of sine to both sides, this sine cancels out because it's really like sine divided by itself. So we get 1x equals inverse of sine, 0.7071. So I'll simply push the inverse sign in my calculator. I'll push the shift or second button and then sine. And it's 45 degrees. So if we follow the steps of using PEMDAS backwards, and then at the end you can use the inverse of sine or cosine or tangent, this will work for trigonomic algebra problems as well. One last thing to consider, we didn't do a problem with a fraction. So let's say x over 2 plus 4 equals 10. So we follow the same process. We ask for any addition or subtraction. And we have an addition plus 4, so I'm going to subtract 4 on both sides. I now have x over 2 equals 6. Well, one thing we can't forget is this fraction sign is also considered a division. So x over 2 really means x divided by 2. So when I ask are there any multiplication or division, I have a division. So I'm going to do the opposite to both sides. Multiply both sides by 2. And this cancels it out. The 2 over 2 becomes 1. So 1x equals 6 times 2, or 12. So just like 2x really means 2 times x, x over 2 means x divided by 2. So we can remember the opposite of the division is multiplication. Hopefully this helps refresh your memory or helps you understand there's a balance to things. We're following a particular order and you're doing the opposites. Opposite of plus, opposite of multiply, opposite of an exponent. So hopefully this helps you out, and let me know if you have any questions.